So, if you want to find Neanderthal fossils, the short answer is you go to Europe or the Near East. And you find a cave. That's the simple version. But the real story is a lot more interesting. It's not about one single best place. It's about a handful of places that, together, tell us who these people were. The best place isn't a spot on a map. It's a collection of sites that have rewritten our own story. It all started in Germany, in the Neander Valley to be exact. In 1856, workers in a limestone quarry found some bones. They thought it was a bear. Then they thought maybe it was a weird, deformed human. It had a thick brow ridge, a sloping forehead, and stout limbs. A local teacher, Johann Fulrott, realized it was something ancient. And something different. He was right. This was the first recognized Neanderthal. The valley gave them their name, Homo neanderthalensis. This spot is the beginning. It's the place that gave us the question. What was this thing? But it didn't give us many answers. For that, we have to go elsewhere. Let's go to France. France is really the classic heartland for Neanderthal discoveries. If you had to pick one country, this might be it. For a long time, our image of Neanderthals came from a French cave called La Chapelle aux Saints. In 1908, they found a nearly complete skeleton there. They called him the Old Man of La Chapelle. A scientist named Marcellin Boule studied him, and his study shaped our view of Neanderthals for 50 years. Boule reconstructed the skeleton as a stooped, brutish, ape-like creature. He said it had a shuffling walk and a dull intellect. This is where the stereotype of the club-wielding caveman comes from. The problem is, Boule was wrong. He was influenced by the ideas of his time. He wanted to see a clear, straight line of progress from ape to modern human, and he needed the Neanderthal to be a failed primitive side branch. The old man was, in fact, old. He had severe arthritis in his spine, which made him stoop. He had lost most of his teeth. This individual was not a typical, healthy Neanderthal. He was a sick elderly man who had been cared for by his group. He couldn't have survived on his own. The fact that he lived to old age with such ailments tells us something profound. It suggests compassion. It suggests community. So La Chapelle aux Saints is a best place, not because it showed us what Neanderthals looked like, but because it shows us how science can get things wrong and then eventually get them right. It's a lesson in looking again. Not far from there is another French site, La Ferracie. This place is different. It's not about one old man. It's about a family. Researchers found the remains of at least 7 individuals here, including adults, children, and even a fetus. They were arranged in what looked like a deliberate way. An adult male and female were buried head to head. A child was laid in a pit, with a stone slab placed over its head and body. This looks like a cemetery. It looks intentional. This was a bombshell. The idea that Neanderthals buried their dead was controversial. Burial implies abstract thought. It suggests a belief system, a concept of an afterlife, or at least a deep sense of loss and ritual. La Ferracie forced us to consider that their minds were not so different from our own. It's a place that points to a Neanderthal soul, but our understanding has gotten much more advanced. To see that, we have to go to Spain, specifically a cave system called El Sidron. The story of this discovery is strange. The bones were found in the 1990s by cave explorers. At first, authorities thought they were the remains of people killed during the Spanish Civil War. But scientific analysis showed they were much older, around 49,000 years old. They belonged to a group of 12 Neanderthals. What makes El Sidron one of the best places is not just the number of individuals, but the quality of the preservation. The cave has a very stable, cool temperature. This means that besides bones, something else survived DNA. The science of ancient DNA has completely changed the game. At El Sidron, they were able to extract Neanderthal DNA and start to piece together their genetic code. The results were stunning. We learned that this group of 12 was a family. There were 3 adult males who were closely related, perhaps brothers or cousins. The 3 adult females were not related to the males or to each other. This suggests a social structure where females would leave their birth group to join another. It's a pattern we see in many modern human societies. DNA from El Sidron also gave us clues about their appearance. One analysis suggested some Neanderthals had red hair and pale skin, an adaptation to the low light of Ice Age Europe. From tiny fragments of bone, we learned about their family life and what they looked like. The bones from El Sidron also had cut marks on them, and they had been smashed, as if to get at the marrow inside. This is strong evidence for cannibalism. It's a stark reminder that their world was brutal. Life was hard. We don't know why they did it. Was it for survival, during a time of starvation? Or was it some kind of ritual? We don't know. But El Sidron shows us the full, complex picture. They were a family. They may have had red hair, and they may have eaten each other. It's a place that reminds us not to simplify the past. Now let's leave Western Europe and travel east. To the crossroads of the world, the Near East is a critical region. This is where Neanderthals, who evolved in Europe and Asia, likely came into frequent contact with our own species, Homo sapiens, who were moving out of Africa. The caves here tell a story of coexistence and interaction. The most famous site in this region is Shanidar Cave in the Zagros Mountains of Iraq. It was excavated in the 1950s by Ralph Selecki. He found the remains of 10 Neanderthals. One of them, Shanidar 1, was an old man, much like the one from La Chapelle. He had suffered a crushing blow to the side of his head when he was young, which likely blinded him in one eye. His right arm was withered and had been amputated above the elbow. He walked with a limp. Yet he survived for years with these crippling injuries. He could not have hunted effectively. He must have been fed and protected by his group. Again, this points to a society with deep social bonds and a capacity for empathy. But another individual from Shanidar Cave, Shanidar 4, is even more famous. This is the flower burial. When Selecki excavated this skeleton, he took soil samples from around the body. For later analysis of these samples found large clumps of pollen, and not just any pollen. It came from several species of brightly colored wildflowers. Selecki proposed a beautiful romantic vision the Neanderthals had laid their companion to rest on a bed of flowers. It was a powerful image. It suggested they had a sense of beauty and engaged in rituals just like us. For decades, this was a key piece of evidence for Neanderthal humanity. But science keeps moving. More recent analysis has challenged this idea. Some researchers now think the pollen could have been brought into the cave by burrowing rodents. Or it could have just blown in. The debate is still open. But even if the flower burial story isn't true, Shanidar Cave remains one of the most important sites. It shows us individuals who lived hard lives and were cared for by others. And recently, new excavations at Shanidar have found another more complete Neanderthal skeleton. The story of this cave is not over. Just south of Shanidar, in modern-day Israel, there are other crucial caves. At a site called Kebara Cave, they found a stunningly complete Neanderthal torso and pelvis. But the most important discovery was a tiny piece of bone called the hyoid. The hyoid bone is located in the neck and it supports the tongue and larynx. It's essential for speech. In apes, the hyoid bone is very different from ours. But the Neanderthal hyoid from Kebara was virtually identical to that of a modern human. This is powerful evidence that their vocal anatomy was like ours. It doesn't prove they had complex language, but it strongly suggests they had the physical capacity for it. They could have spoken. Think about what that means. They could have told stories. They could have planned hunts. They could have passed down knowledge. The little bone from Kebara Cave opens up the possibility of a Neanderthal voice. Nearby, at Amud Cave, another discovery was made. They found the skeleton of a Neanderthal with the largest brain of any hominin ever found. Its brain was significantly larger than the average for modern humans. This directly contradicts the old dumb brute stereotype. Brain size isn't everything, of course, but it shows they were not a small-brained, unintelligent species. They had the hardware for complex thought. When you combine this with the evidence for hunting, toolmaking, and possible burials, a picture emerges of a highly capable and intelligent people. So, we have the classic sites in Western Europe and the crossroads in the Near East. But the story doesn't end there. To find some of the most revolutionary discoveries, you have to go to the fringes of their known world. To places that are colder and more remote. Let's go to Croatia, to a site called Vindija Cave. It's not a spectacular cave. The fossils found there are mostly small, broken fragments. For a long time, it was just one of many Neanderthal sites, but like El Sidron, its importance exploded with the arrival of genetic science. The fragments of bone from Vindija, though small, had incredibly well-preserved DNA. These tiny pieces became a cornerstone of the Neanderthal Genome Project. This massive undertaking, completed in 2010, mapped the entire genetic code of a Neanderthal. The results were world-changing. The project confirmed that Neanderthals were a separate lineage from us, but a very close one. The most shocking discovery was that most modern humans outside of Africa carry a small amount of Neanderthal DNA in their own genomes, usually between 1 and 2%. What does this mean? It means our ancestors and Neanderthals met, and they had children together. This wasn't a rare event. It happened often enough to leave a permanent mark on our own species. We are, in a small way, part Neanderthal. The evidence for this interbreeding was written in the fragments from Vindija Cave. It dissolved the clear line we once drew between us and them. The story was no longer about a simple replacement. It was about a complex and messy interaction. The final place, and perhaps the most mind-bending of all, is even further east. It's a cave in the Altai Mountains of Siberia. It's called Denisova Cave. This place is cold, extremely cold. That cold is the key. It's a perfect natural freezer, preserving ancient molecules for tens of thousands of years. The scientists digging in Denisova Cave found a tiny fragment of a finger bone from a young girl. It was too small to tell what kind of hominin it belonged to just by looking at it. So, they decided to test its DNA. Everyone expected it to be either a Neanderthal or a modern human. It was neither. The DNA belonged to a completely new group of ancient humans, one that science had never known about. They were named the Denisovans after the cave where they were found. This one tiny bone revealed an entire lost branch of the human family tree. But what does this have to do with Neanderthals? Well, as they continued to analyze the DNA from Denisova Cave, they found more surprises. They found Neanderthal DNA too. The cave had been used by both Neanderthals and Denisovans at different times. Then, they found a bone fragment from a teenager who lived around 90,000 years ago. They tested her DNA. The results were unbelievable. Her mother was a Neanderthal. Her father was a Denisovan. She was a first-generation hybrid. Her nickname is Denny, and she is direct, physical proof that these different human groups were meeting and having children. Denisova Cave is not just a Neanderthal site or a Denisovan site. It's a place that shows us a lost world where several kinds of humans coexisted. It was a world far more complex than we ever imagined. The Neanderthals from this cave represent the easternmost extent of their known range. They were an incredibly successful and widespread people, stretching from Spain to Siberia. So, where is the best place to find Neanderthal fossils? There is no single answer. The Neander Valley in Germany is the best place to find the beginning of the story. La Chapelle and La Pharisee in France are the best places to understand how our view of them has changed, from brutish ape men to complex people who cared for their sick and buried their dead. And El Sidron in Spain is the best place to see their family life written in their genes. Shanidar Cave in Iraq is the best place to contemplate their capacity for compassion. Kabara Cave in Israel is the best place to imagine the sound of their voice. Vindija Cave in Croatia is the best place to find the proof that we carry a piece of them within us. And Denisova Cave in Siberia is the best place to understand that their world was bigger and more complex than we ever dreamed. The real answer to the question has less to do with geography and more to do with geology and history. Neanderthal fossils are found where conditions are right for preservation. That usually means limestone caves. Caves are natural shelters. They protect bones from the sun, the rain, and from being trampled or scattered by scavengers. Over time, sediments wash into the cave, burying the bones quickly. This quick burial is key. It keeps the bones safe. The stable temperature and chemistry inside a cave help the slow process of fossilization, where minerals gradually replace the organic material in the bone. So, the best place is almost always a cave, and the reason so many of these caves are in Europe and the Near East is twofold. First, this was their primary homeland. They evolved and lived in this region for hundreds of thousands of years during the ice ages. Their population was concentrated there. Second, there's a historical bias. Paleoanthropology as a science was born in Europe. People have been systematically looking for ancient human remains in Europe for over 150 years. We've found a lot of sites there because we've been looking there for a long time. It's possible there are Neanderthal sites and other places that we simply haven't found yet. The search is not over. New sites are still being discovered, and old sites are being re-examined with new technology. We can now learn more from a single tooth than we once could from an entire skeleton. We can extract DNA, analyze the chemical isotopes to learn about diet and migration, and study the microscopic wear and tear on teeth to understand what they ate and how they used their mouths as a third hand. The best place to find a Neanderthal fossil, then, is in a lab, re-examining a fragment that was dug up 50 years ago. It's in the data from a DNA sequencer, it's in the arguments between scientists about what it all means. The physical locations are just the start. They are the scattered pages of a long and complicated book. By visiting each one, by piecing together the clues from France, to Iraq, to Siberia, we slowly start to read the story of a lost human family. Our family. The search for them is, and always has been, a search for a deeper understanding of ourselves.